Welcome back friends in my YouTube channel TechTide Digital Lifestyle for the Induction Motor Complete course, and today in day 6 we are going to study the starting methods of induction motors. Before start the lecture, please like and subscribe my YouTube channel. Starting an induction motor is not as simple as switching it on, because at starting the rotor is stationary, slip is equal to 1, and therefore the motor draws very high starting current, which can be 6 to 8 times the full load current. This high current can damage the windings, create severe voltage drop in supply lines, and put mechanical stress on the rotor and driven load. Therefore, special starting methods are used to limit starting current and provide smooth acceleration. The simplest starting method is direct online DOL starter, where full supply voltage is applied directly to the stator. This method is cheap, simple, and reliable, but produces very high starting current and high starting torque. DOL starters are only suitable for small motors, typically below 5 HP, where supply and mechanical stresses are manageable. For medium-size motors, star-delta starter is widely used. In this method, the motor initially starts in a star connection, reducing phase voltage to 58% of line voltage. As a result, starting current is reduced to about 33% of the DOL value, and starting torque is also reduced. After the motor reaches approximately 80% of full speed, the starter switches to delta connection, allowing the motor to run at full line voltage. This method is cost-effective and commonly used for motors from 5 HP to 50 HP. The auto transformer starter is another method for larger motors. It provides reduced voltage starting by using a tapped auto transformer, allowing adjustable starting voltage. This results in smooth acceleration and moderate starting current. Although this starter is more expensive, it is highly effective for motors where voltage drop or mechanical shock is a concern. For slip ring motors, the rotor resistance starter is preferred. In this method, external resistors are connected in series with the rotor winding. The resistors limit rotor current at start, increase starting torque, and provide smooth acceleration. Once the motor reaches near full speed, the resistors are short-circuited. This method is only applicable to slip ring induction motors because rotor resistance in squirrel cage motors is fixed and cannot be varied. A comparison of all starters is important for exams. DOL provides high starting torque and high current at low cost for small motors. Star delta reduces starting current and torque to 1/3, suitable for medium motors. Auto transformer allows adjustable current and torque for large motors but is expensive. Rotor resistance provides high starting torque with adjustable current for slip ring motors. We also need to remember some important formulas. For star delta starter, phase voltage in star connection is line voltage divided by square root 3. Therefore, starting current is full load current divided by square root 3. For an auto transformer starter, starting current equals line current multiplied by the reduced voltage ratio. These formulas are often asked in ETO and COC examinations. From an exam perspective, make sure you can draw connections for all starters, explain how starting current and torque are reduced, compare the methods, and explain in which situations each starter is used. Knowing these clearly will help you answer both theory and numerical questions. To summarize day 6, we learned why special starting methods are needed, detailed explanations of DOL, star delta, auto transformer, and rotor resistance starters, their comparison, important formulas, and exam-oriented points. In the next lecture, day 7, we will cover performance characteristics and speed control of induction motor. Thanks you for watching this video. Please like and subscribe my YouTube channel TechTide Digital Lifestyle.